To my dear lovable students, welcome to Max class. In this conversation, we are going to discuss about exercise 4.4, question number 1. Okay, one by one we can discuss. Okay, question: by the principle of mathematical induction, prove that for n greater than or equal to 1, condition 1 cube plus 2 cube plus 3 cube plus dot 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 plus n cube is equal to n into n plus 1 over 2 the whole square. Condition, just to consider for P of n is equal to 1 cube plus 2 cube plus 3 cube plus dot 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 plus n cube is equal to n into n plus 1 by 2 the whole square. Instead of n, take it P of 1 means what will happen? LHS n cube. N cube means 1 cube. Value we have 1. In RHS, right hand side, what is the value? 1 into 1 plus 1 by 2, the whole square. So 1 plus 2, 2. 2 divided by 2 means cancel only 1. Therefore, 1 whole square means 1. Now we can say LHS is equal to RHS. Therefore, P of 1 is true. Then condition, assume P of K is true. So, if you take P of K is true means instead of n each and every places we should be writing K. What will happen? P of K 1 cube, 2 cube, 3 cube dot 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 plus n k cube then is equal to K into K plus 1 over 2 the whole square. Again, to prove P of K plus 1 is true. So, P of K plus 1 is true means P of K plus 1 means 1 cube, 2 cube, 3 cube dot 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 plus K cube plus K plus 1 the whole cube is equal to instead of K we can write it K plus 1. Again already this is equating K plus 1 means already plus 1 is, therefore plus 1 means plus 2 will come. So K plus 2 divided by 2 the whole square. Now take it for only the left hand side value. So LHS means what will happen? Instead of plus K cube, what is the value is there? K into K plus 1 by 2 the whole square. So K into K plus 1 by 2 the whole square. Again plus K plus 1 the whole cube. Now if you remove the bracket means what will happen? K into square means K square plus, not plus, isn't it? So K square into K plus 1 the whole square divided by 4 because 2 square means 4 plus K plus 1 the whole cube. Again here also K plus 1 the whole square is there, K plus 1 the whole cube is there. Take it outside, K plus 1 outside means what will happen? K into K square, K plus 1 the whole square means inside. So K square, then K square by 4 plus K plus 1 because square taking common outside, no? Again K plus 1 the whole square into, simplify means K square, 4 into K, 4K plus 1 into 4, 4 divided by 4. Again K plus 1 the whole square into, this is nothing but K plus 2 the whole square because A plus B the whole square means A square plus 2AB plus B square. So we can write it K plus 2 the whole square divided by 4, divided by 4 is there, we can write it 2 square now. Again this whole term consider for K plus 1 into, again K plus 2 into divided by 2 the whole square. This is nothing but RHS. Check it there. This is our RHS term. So RHS K plus 1 into K plus 2 divided by 2 the whole square. Therefore, the final line, P of K plus 1 is true. So P of K plus 1 is true means we can say P of n is true. Therefore, for all integer for all integer n belongs to natural number. Okay, I will continue the second question from exercise 4.4. Okay, please stay on the line. Moving to question number 2 from exercise 4.4. Question: by the principle of mathematical induction, prove that for n greater than or equal to 1, condition is there. First, what we have to do, P of n is equal to 1 square plus 3 square plus 5 square plus dot 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 2n minus 1 the whole square is equal to n into 2n minus 1, then 2n plus 1 over 3. Now, apply for P of 1 means LHS 2n minus 1 the whole square. So, 2n minus 1 the whole square means 2 into 1 means 2. 2 minus 1 the whole square means only 1. Then RHS 1 into 2 into 1 means 2 minus 1 again. So, 2 into 1 2 plus 1. The whole term divided by 3 means 2 plus 1 3. 3 cancel means 1 into 2 minus 1 value we have 1. Therefore, LHS is equal to RHS means we can say P of 1 is true. First condition is clear. Then we have to assume P of k is true. Assume P of k is true. What will happen? P of k is true means P of k 1 square 3 square plus 5 square dot 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 plus instead of n you can take it 2k. So, 2k minus 1 the whole square is equal to k into 2k minus 1 again 2k plus 1 over 3. Then to prove P of k plus 1 is true. So, P of k plus 1 is true means P of k plus 1 1 square 2 square, sorry my dear, this is 3 square 5 square plus dot dot dot. So, 2k minus 1, isn't it? So, 2k minus 1 the whole square, then plus instead of k 2k minus 1 the whole square means 2 into k means what is the meaning? K plus 1 minus 1 the whole square. Therefore, remove the bracket 2k plus 2 minus 1. Therefore, 2k plus 2 minus 1 means plus 1. So, 2k plus 1 the whole square. Here 2k plus 1 the whole square is equal to k plus 1 into 2k minus 1. So, 2k minus 1 already we know what is the meaning, 2k plus 1 will come. So, 2k plus 1, then 2k plus 1. 2k plus 1 means 2 into k plus 1 plus 1. Therefore, 2 into k 2k plus 1 into 2 plus 1. Therefore, 2k plus 3. Here what's the value? 2k plus 3, isn't it? 2k plus 3, the whole term divided by 3. Now I am moving to take it for only LHS term. So, LHS means look at there. So, instead of 1 square 3 square 5 square plus dot 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 2k minus 1 the whole square means what is the meaning? K into 2k minus 1, then 2k plus 1 divided by 3 plus 2k plus 1 the whole square. So, 2k plus 1, first term also 2k plus 1 is, take it common outside means 2k plus 1 into k into 2k minus 1 over 3 plus only 2k plus 1 will come because square we have taken for outside. Then 2k plus 1, so k into 2k minus 1 plus 3 into 2k plus 1, the whole term divided by 3. Next step, 2k plus 1, you can remove the bracket means 2k into k means 2k square minus 1 into k minus k. Again next term 3 into 2k means 6k, then plus 1 into 3 means plus 3. whole term divided by 3. Again 2k plus 1, 2k square plus 6k minus k means plus 5k plus 3 divided by 3. Now 2k plus 1, then sum product rule. Product means 2 into 3, 6 will come. Product means 2 into 3, 6. Sum means plus 5. Therefore, we can say 2 comma 3. Look at there. Already I told you, if you have product positive sign means selected to same sign. Whether positive or negative, we have the positive. Therefore, 2 plus 3 is equal to sum 5. 2 into 3 means positive 6. Therefore, 2k square, instead of 5k, we can take it plus 2k plus 3k plus 3 whole term divided by 3. Next one, 2k plus 1 as it is, 2k plus 1, then inside 2 take common outside means, otherwise 2k take common outside, inside k plus 1, next condition also, plus 3 take common outside means k plus 1, whole term divided by 3. Again 2k plus 1 into common factor k plus 1 into 2k plus 3, the whole term divided by 3. This is called RHS. What is RHS term? 2k plus 1. 2k plus 1. Then, where is our RHS term there? Yeah, sorry, here. K plus 1 is there. Then 2k plus 3 there. Then another one 2k plus 1 divided by 3. This is called RHS. Therefore, we can say P of k plus 1 is true. So, P of k plus 1 is true means P of n is true. Therefore, for all integer n greater than or equal to 1 by principle of mathematical induction. Okay, I will continue the next question. Question number 3. Condition, prove that the sum of the first n non-zero even integers, starting with also without 0, okay, because non-zero even integers means we can take it one equation 2 plus 4 plus 6 plus dot 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 plus n square is equal to n square plus 1, the normal condition. What is the condition? First, P of n is equal to 2 plus 4 plus 6 plus dot 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 plus n square is equal to n square plus n. Then consider for P of 1 means what will happen? True. RHS, LHS means what will happen? P of 1 means LHS n square is, therefore 1 square is equal to 1 will come. RHS 1 square means 1 plus 1 is equal to 2, isn't it? So now look at there, the condition 1 square is equal to, it's not equal now, listen here. This is 2n dear, this is actually 2n. Here also 2n. How? First one, so instead of n, take it 1 means what will happen? Each and everything take it 1 means, so 1 into 2 means 2. Look at there, 1 into 2 is equal to 2. The next condition, here also if you take it 1 means, 1 square means 1, 1 plus 1 is equal to 2. It's correct now. The next condition, take it 2. So 2 into 2, 4. Opposite side also, 2 square means what the value is there? So look at there, 2 means 2 will come. This is a considered the term. So 2n only it's correct. Then only we can say the sum of the first n non-zero even integers. Next condition, take it 3 means 2 into 3, 6. This is the way. Okay, therefore 2 plus 4 plus 6 plus dot dot dot, what is the meaning? 2n, that is equating for n square plus n. Now, first condition, RHS, what is the meaning? Here actually 2 into 1, isn't it? So 2 into 1 means true will come. Therefore, opposite side also 1 square plus 1. That 1 plus 1 is equal to true. Again, assume, first you can write it, P of 1 is true. So P of 1 is true means assume P of k is true. What will happen? So P of k true plus 4 plus 6 plus dot dot dot. Instead of 2n we can write it 2k is equal to k square plus k. Now to prove P of k plus 1 is true. So P of k plus 1 is true means P of k plus 1, 2 plus 4 plus 6 plus plus 2k plus 2 into k plus 1 means we can write it 2k plus 2 is equal to k square means we can write it k plus 1 the whole square again plus k plus 1. Then opposite side k plus 1 take it common outside means inside what will happen? Only k plus 1 will come. Therefore k plus 1 into k plus 2 will come. Now I am going to check LHS and RHS. LHS means instead of 2 plus 4 plus 2k means what is the meaning? K square plus k. K square plus k remaining the term plus 2k plus 2. Now k square plus otherwise first two term look at that k take common outside means k plus 1 will come. Next one plus 2 take common outside means k plus 1. Again common factor k plus 1 take outside means inside k plus 2. Look at there, this is called RHS. K plus 1 into k plus 2. K plus 1 into k plus 2. Therefore we can say P of k plus 1 is true. So P of k plus 1 is true means we can say P of n is true. Therefore for all integer n belongs to natural number. Okay, I will continue the next question. Moving to question number 4. By the principle of mathematical induction, prove that n greater than or equal to 1. Condition 1 into 2 plus 2 into 3 plus 3 into 4 plus n into n plus 1 is equal to n into n plus 1 into n plus 2. This whole term consider for P of n means 1 into 2 plus 2 into 3 plus 3 into 4 plus n into n plus 1 is equal to n into n plus 1 into n plus 2 over 3. Consider for P of 1 means what will happen? LHS n into means 1 into 1 plus 2. Therefore 1 into 1 plus 2 means 1 plus 2 means 3. 3 into 1 means 3. Then RHS 1 into 1 plus 1 into then 1 plus 2. Therefore whole term divided by 3 means 1 into 1 plus 2, isn't it? Sorry my dear, 1 into 1 plus 2. Therefore 1 plus 2 means 3 cancel, 1 plus 2. Sorry my dear, this is actually 1 into 1 plus 1. Now 1 plus 1 means 2, 2 into 1 means 2. Therefore here also 2 will come. Therefore we can say LHS equal to RHS. So P of 1 is true. Then P of 1 is true means assume P of k is true. So P of k is true means P of k means 1 into 2 plus 2 into 3 plus 3 into 4 plus k into k plus 1 is equal to k into k plus 1 into k plus 2 whole term divided by 3. To prove P of k plus 1 is true. So P of k plus 1 is true means P of k plus 1 into 2, 2 into 3, then 3 into 4 plus k plus 1 into, sorry my dear, first we have to write it. What is the meaning? This is a condition plus k into k plus 1, then plus again instead of k we can write it k plus 1 into k plus 2 is equal to opposite side k plus 1, there is already plus 1 is there, therefore we can write it k plus 2, plus 2 is there, therefore we can write it k plus 3, the whole term divided by 3. Now we can check it LHS. So LHS instead of k into k plus 1, we can write it k into k plus 1 into k plus 2 divided by 3. Then plus k plus 1 into k plus 2. See, first term also k plus 1 into k plus 2. Second term also k plus 1 into k plus 2. Take common outside, means k plus 1 into k plus 2. Then inside k by 3 plus 1. Therefore, k plus 1 into k plus 2 into, simplify means it 1 into 3, 3. So, k plus 3 divided by 3. Therefore, this is called k plus 1 into k plus 2 into k plus 3, the whole term divided by 3. This is called RHS. So, we can say P of k plus 1 is true. So, P of k plus 1 is true means we can say P of n is true. Therefore, by the principle of mathematical induction, n greater than or equal to 1, hence proved. Okay, I will continue the next question. Question number 5. Using the mathematical induction, show that any natural number starting n greater than or equal to true. Okay, so just to consider P of n means 1 minus 1 by 2 square, again 1 minus 1 by 3 square, then 1 minus 1 by 4 square plus dot 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 plus 1 minus 1 by n square is equal to n plus 1 over 2n. So, let us assume P of 1 means LHS. What is LHS, Ram? 1 minus 1 by 1 square, isn't it? Sorry, my dear. The condition greater than 2, isn't it? So, starting here also we have to write it true. Therefore, here what will happen? 1 minus 1 by 2 square will come. Then, therefore, 1 minus 1 by 4 means LCM 1 into 4, 4. 4 minus 1 by 4 means we have 3 by 4 in LHS. Then RHS n plus 1. n plus 1 means 2 plus 1 over 2 into 2, isn't it? Therefore, 2 plus 1 means 3 by 4. See, LHS is equal to RHS. So, LHS is equal to RHS means we can say P of 1 is true. First condition is clear, isn't it? Moving to second one. Second one means assume P of k is true. Assume P of k is true. So, P of k is true means instead of n we have to apply P of k 1 minus 1 by 2 square, then 1 minus 1 by 3 square dot 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 plus 1 minus 1 by k square is equal to k plus 1 divided by 2 into k plus 1. So, to prove P of k plus 1 is true. So, P of k plus 1 is true means P of k plus 1 minus 1 by 2 square, then 1 minus 1 by 3 square dot 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 plus 1 minus 1 by, instead of, first we have to write it as it is. What is the term? 1 minus 1 by k square plus 1 minus 1 by, instead of k we can write it k plus 1 the whole square is equal to, there what will happen? K plus 1 is there. Therefore, we can write it k plus 2. So, k plus 1, isn't it? So, k plus 1 means instead of k, take it for k plus 1, already plus 1 is, therefore, we can write it k plus 2. Again divided by 2 into, already k plus 1 is, therefore, we can write it 2k plus 2, isn't it? So, now k plus 1, k plus 2 is there. Condition is clear. Sorry, my dear, here 2n, no, 2n means we can write it only 2k. So, only 2k means k plus 2 divided by 2 into k plus 1. Now, it is correct. So, LHS, instead of 1 minus 1 by k square, we can write it k plus 1 over 2k. K plus 1 over 2k plus 1 minus 1 by k plus 1 the whole square. So, now k plus 1 divided by 2k plus Simplification means 1 into k plus 1 the whole square means k plus 1 the whole square. K plus 1 the whole square divided by that minus 1 divided by k plus 1 the whole square, isn't it? Sorry my dear, this is actually into condition. Into means condition also each and every bracket into term, no? So into means look at there 1 minus 1 by k plus 1 the whole square. So here also so into 1 minus 1 by k plus 1 the whole square. Now first term as it is k plus 1 by 2k. Next one simplify means k plus 1 the whole square minus 1 divided by k plus 1 the whole square. So square and k plus 1 cancel, then remaining k plus 1 the whole square minus 1 divided by k plus 1 into 2k. A plus b the whole square form means a square plus 2ab plus b square. Therefore we can write it k square plus 2k plus 1 minus 1 divided by 2k into k plus 1. So plus 1 minus 1 cancel, then balance k square plus 2k divided by 2k into k plus 1. Numerator k take common outside means k plus 2 divided by there is 2k bracket of k plus 1. Again k cancel means k plus 2 divided by k plus 1. Outside 2 is there, isn't it? Now look at there k plus 2. K plus 2 denominator 2 into k plus 1. This is called RHS. Therefore we can say what we can say. So now P of k plus 1 is true. P of k plus 1 is true means P of n is true. Therefore for all integer n greater than or equal to true. Okay, I will continue the next question. Question number 6. The same concept, but question is a little bit different. Comparing the last question, 1 by 1 plus 2 plus 1 by 1 plus 2 plus 3 plus 1 by 2 plus 3 plus 4 dot 1 by 1 plus 2 plus 3 plus dot n is equal to n minus 1 over n plus 1. First you have to consider for P of n is equal to 1 by 1 plus 2 plus 1 by 1 plus 2 plus 3 dot plus 1 by 1 plus 2 plus dot plus n is equal to n minus 1 over n plus 1. So assume P of 1 is true. So P of 1 means, look at there, some of the students will be think own self. There is one more term is possible now, because 1 by 1 plus 1 by 1 plus 2, 1 by 1 plus 2, that is a basic, isn't it? But the given condition always n greater than or equal to true. If you take it 1 by 1 means, look at there, first you have to imagine it. Only second term only consider means what the meaning will come. 1 by 1 plus 2 means definitely 1 by 3 will come. So instead of 1 by 1 apply there means this is also P of 1 is not possible. Why? The condition is starting with always true. So P of true only. So 1 by 1, if you take it, there is also 1 consider means what will happen? 1 by 1 means value we have 1. So if it apply 1 instead of n, take it 1 means 1 minus 1, 0 is there. That's why that is a statement is not true. That's why the given the natural number also always starting with the n greater than or equal to true. Okay. So 1 by 1 plus 2 only, it's a correct statement. Okay, 1 by 1 plus 2 is equal to 1 by 3 means opposite side, look at there, P of 2 means you will get it correct answer. 2 minus 1 means definitely this is called RHS. 2 minus 1 divided by 2 plus 1. Therefore 2 minus 1 is equal to 1, 2 plus 1 is equal to 3. Now we can say LHS is equal to RHS. Therefore we can say P of 1 is true. So P of 1 is true means next condition assume P of k is true. So P of k is true means P of k 1 by 1 plus true, then 1 by 1 plus 3, sorry my dear, 1 plus 2 plus 3, then 1 by 1 plus 2 plus 3 plus 4 dot 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 1 by 1 plus 2 plus dot 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 plus k is equal to k minus 1 over k plus 2. Sorry, k minus 1 over k plus 1. Then to prove P of k plus 1 is true. So k plus 1 is true means P of k plus 1 1 by 1 plus 2, then plus 1 by 1 plus 2 plus 3 plus 1 by 1 plus 2 plus 3 plus 4 dot 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 1 by 1 plus 2 plus 3 dot 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 plus k plus 1 by 1 plus 2 plus 3 dot 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 plus k plus 1. This whole term is equal to, instead of k, take it k plus 1 means plus 1 minus 1 cancel, therefore k divided by k plus 2 will come. So we have to show in right hand side k over k plus 2. So LHS, instead of the whole term, what is the meaning? K minus 1 over k minus 1 over k plus 1, then plus 1 by 1 plus 2 plus 3 plus dot 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 plus k plus 1 is there. Already we know it's a particular term from example 4.61 condition is there. Example 4.61, you can check it there. Condition 1 plus 2 plus dot 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 plus n is equal to, what is the formula? N into n plus 1 by 2. If it apply instead of n, k means what will happen? 1 plus 2 plus dot 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 plus k is equal to k into k plus 1 by 2. So to prove P of k plus 1 is true means what will happen? Again 1 plus 2 plus 3 plus k plus 1 is equal to again k plus 1 into k plus 2 over 2 will come. So instead of k plus 1, look at there, instead of k plus 1 is equal to, we can take now what is the value? K plus 1 into k plus 2 over 2. Therefore k minus 1 over k plus 1. So k minus 1 over k plus 1 plus 1 by k plus 1 into k plus 2 over 2. Therefore k minus 1 over k plus 2, then plus reciprocal means 2 divided by k plus 1 into k plus 2. Now 1 by k plus 2 take common outside means 1 by k plus 2 take common outside means k minus 1 plus 2 by k plus 1. Therefore 1 by k plus 2. So simplify means k plus 1 into k plus 1 into k minus 1 sorry my dear, my mistake. This is k minus 1, k plus 1. It's also k plus 1, here also k plus 1. So now look at there, k plus 1 take it outside means there is 1 by k plus 2 will come, isn't it? So this is actually 2 by k plus 1 into k plus 2. Here also k plus 1 take it outside means 2 by k plus 2. Here actually k plus 2. Then k minus 1 into k minus 1 into k plus 2 divided by k plus 2, isn't it? So now after getting this line, what we have to do, look at outside 1 by k plus 1, then bracket of, if you remove the bracket means k into k, k square, then plus 2 into k, plus 2k, minus 1 into k, minus k, minus 1 into 2, minus 2. Then outside plus 2 is there, divided by k plus 2. Again minus 2 plus 2 cancel. One by k plus 1. So k square plus 2k minus k. Therefore we can say no, 1 by k plus 1, then k square, 2k minus k means only k will come, divided by k plus 2. Next term, outside common, 1 by k plus 1 is there, then inside k take common outside means definitely k plus 1 divided by k plus 2. Again what will happen? K plus 1 cancel. Okay, this is as it is, k plus 2. Therefore after cancellation, balance k by k plus 2. We have to show k by k plus 2. This is called RHS. Therefore P of k plus 1 is true. So P of k plus 1 is true means definitely we can say P of n is true. Therefore for all integer n greater than or equal to true by the principle of mathematical induction. Okay, so please listen my dear students. I hope you are satisfied in this session. I will continue the next session, continuation of exercise 4.4. So don't worry my dear students, I am always with you. If you have any doubt, please put in comment box. I am ready to clarify your doubts. Okay, I will continue the next session. Bye bye.